Okay. So we learned that local variables are stored in the stack frame of the corresponding method. Now let us talk about this mobile m is equal to new mobile. What happens at this line? So at this line, mobile m is equal to new mobile. A new object is created in the heap area. So here you can see we have our heap area, and inside it, at this line new mobile, a new mobile object is created, but it is not pointing to anywhere. And where this so we now learned that a new object, whenever new keyword, a new object is always going to create in the heap area. So here we have in the heap area, which I showed you already, that in the heap area we are going to have a mobile object. Okay, a new mobile object, and where this mobile m, that is this reference, will be created. So let us learn about that. Since the same thing, so here you can see this reference variable will always be created in the stack frame of the corresponding method. Here in our case it is main method. So in the stack frame of the main method, we will have a reference variable m that will point to a new object, that is mobile. So here you can see we have our reference m, that is a reference, you can see here, and we have this reference is always created in the stack frame. So here we can say in the stack frame, that is stack area, stack frame, we are going to have our variable, reference variable m. Now this reference at this line mobile m, here we have our reference variable is always created in the stack frame of the corresponding method. In this case we are having our method name as main, and this equals operator is simply to assign this object to the reference object to the reference variable. So this reference variable now points to this. So simply just like this, that we have our reference variable, and we have our, here we have our mobile object, and now we will connect. This equal to sign is nothing but the wire in our case. Okay, so now we connect our this. So this is the meaning of this line, mobile m is equal to new mobile. So let me conclude here that local variables are stored in the stack frame, and also the reference variables are stored in the stack frame, reference variables. Okay, so both of these, that is reference variable and local variables, both are stored in the stack frames, and a new object is always created in the heap area. There should be no doubt regarding this, that object will be created or stack or heap. Whenever new keyword, surely we are going to create a new object in the heap area. Okay, so a mobile object is created in the heap area here, and the reference variable is always created in the stack frame of that particular method. Now think of a scenario when we are having another method inside this main method. What will happen at this line? Suppose I have a method crawl, and I am passing value 4 to it. Okay, we have a new method, this crawl, and we are calling by passing the value. So here let us suppose our crawl method is public void crawl, and since we are passing a parameter, so it should receive a parameter. Suppose it is integer value int x, and we are opening the curly brace and closing the curly brace. Okay, so here int x. Now think of it. What will happen when we call this crawl method? This crawl method by passing argument 4. So here we have the declaration of this method crawl int x is equal to we are passing this parameter int x, and inside it we are declaring a new variable that is int z, and we are assigning z is equal to x plus 1. So what happens at this line? At this line what happens? We are having a main method, and inside main method, this is a stack frame of the main method. Inside it we are having our I and m. After that, at this line what happens? We are having the main frame, that is a stack frame for the main method, and inside this main method we are calling an other method, that is the crawl method. So here what will happen? A new stack frame for the crawl method will be created. So here you can see a new stack frame for the crawl method is created, and it will be on the top of the previous stack frame of the main method. So since this crawl method is called inside this method, that is main method, so new stack frame for the new method, that is crawl method, will be created. And what will happen? This parameter int x, will be inside this crawl. Okay, so where this x is situated? This x is situated inside or located inside the crawl method, the stack frame of the crawl method. So the parameter x is inside the crawl method stack frame. So here you can see we have the integer x value, okay, and it is inside the stack method of stack frame of the corresponding method, that is here crawl method. And also inside the method we have declared int z is equal to x plus 1. So what will happen? We are going to have a new integer z. So here you can see inside the same stack frame of the crawl method we are going to have a new variable, that is z. And what will be its value? Its value will be 4 plus 1, that is 5. Okay. So a new point to be noted here is that a parameter is situated or located where, or created where? A parameter is also created in the stack frame. Parameter created in the stack frame, reference variable created, local variable created in the stack frame. So in one line we can say that local variables, reference variable, parameters, all are created in the stack frame of the corresponding method in which they are called. And suppose there is a scenario inside this we call another method. We may call another method. So suppose we call the method name as walk. So what will happen at this line? What will happen at this line? At this line, since this crawl method is not finished yet, so a new stack frame for the walk method is created. Here you can see the stack frame for the new walk method. Okay, and it will lie on the top of the previous method, that is crawl method. Okay, so now I think you are clear about this stack frame. That is, first of all, main method comes, and inside that crawl method is called, so a new stack frame for the crawl method is called, and before finishing the crawl method a walk method is called. So stack frame for the walk method is created. Suppose this is our stack, then we have our main method here, stack frame main method, then walk, then crawl method, and then walk method stack frame. So here is our stack frame, and inside it what we have? We have I, we have m, these are reference variable, and in case of crawl we have x, we have z. Okay, the same way walk method. What happens? Let me conclude here that when this walk method completes, then stack frame for this is destroyed. And what happens at this line? This stack frame is destroyed means all the variables which were declared inside this method are destroyed. Okay, now what happens? The control reaches to this crawl method, and it comes to this line, that is crawl method finishes, then what will happen at this line? The stack frame of the crawl method is destroyed, and all the variables, all the reference variables, whatever it declared, are destroyed. Okay, now control reaches to this main method, and what will happen? All the reference variable, all the local variables are destroyed, and this whole stack frame are destroyed, and this stack is empty. So simply, first of all, what will happen? This walk method pops out of the stack frame. First of all, it is destroyed, then crawl method is destroyed, then main method is destroyed. So you can see that last in first out, that is walk was the last method which was called, but it was destroyed first, then crawl, then main method. So this was the concept of the last in first out, and how stack frames are created and destroyed while calling a method or while method during method invocation. So what happens to this object? This object in the heap area, that is this object in the heap area, it is still lying here, is still lying here. So it is in the heap area, and there is no reference pointing to this. So now this object in the heap is eligible for the garbage collection. So we will learn about garbage collection in later videos, but for now keep in mind that this mobile object which is created inside the heap area is lying there. It is not destroyed. It is not destroyed. It is not destroyed when the stack frame of the corresponding method in which it declares is destroyed.